Hello everyone, this is Mohammed Mehra Hussain and my ID is 224080003. Today I will be discussing about software architectures in embedded systems. Here are the topics that we are going to talk about. So let us begin with round robin. Round robin is a preemptive CPU scheduling algorithm where each task is assigned a fixed time slice or time quantum in cyclic order. So at first we have to know what is preemptive. Preemptive means the scheduler can interrupt a process which is currently executing, and another higher priority task or process can be executed instead of that currently running task. So how round robin works? The tasks are placed in a ready queue. Each task runs for a fixed time quantum, and if it does not finish within the time, it is preempted. So, preempted means if a process or task does not finish within the time quantum or time slice, another task which is located in ready queue gets the CPU access. So, next we talk about function queue scheduling algorithm. uh, Function queue scheduling architecture. Function queue architecture is a non-preemptive scheduling model where tasks are stored as function pointers in a queue and executed sequentially. So we previously we saw that round robin is a preemptive scheduling architecture or algorithm, but function queue is a non-preemptive scheduling. So what does non-preemptive mean? Non-preemptive means if we start executing a process or task, no matter how long it takes to execute, we finish executing this task first. And after executing this task, then we start executing another task. So here is how function queue scheduling architecture works. So now we move to real-time operating system architecture. Uh, then we have to understand what is real-time systems. Real-time systems means systems that are composed of two or more cooperating concurrent processes with stringent execution time constraints. So, what is cooperating process or concurrent process? Cooperating process means a process which can affect another process or it can be affected by another process. And concurrent process means two or more processes that are being executed simultaneously. And real-time operating system or RTOS means the operating systems that are designed to serve the purpose of this real-time application. They process data as it comes in, typically without buffer delay. So the characteristics of the real-time operating system. The first characteristic is deterministic scheduling. It means that the tasks are executed within strict time constraint, and the delay can cause a catastrophic loss. And the next is low latency. It means the between an event and the response there is minimal delay. And the next characteristic is priority based task management. It means that a higher priority task can preempt a lower priority task. And the next is reliability. Reliability means that real-time operating systems are used in critical mission applications where a delay can be harmful. So there are two examples of real-time operating systems we talk about. One is QNX and the other is Windows CE. QNX is a real-time operating system developed and maintained by BlackBerry Limited, and Windows CE is another real-time operating system and which was designed and developed by Microsoft, and currently it has been discontinued and replaced by another modern real-time operating system which is Windows IoT. Now we talk about embedded program modeling concepts in single and multiprocessor systems. Here we talk about how engineers conceptually represent and design embedded software depending on whether the hardware has one CPU or multiple CPUs. So it is basically how we design our embedded system for single processor system or multiprocessor system. So modeling in single processor system. Here the modeling focus is on how tasks share one CPU. So there is one CPU and there are many tasks. So we share this one CPU and execute more than one task sequentially. One CPU executes all tasks sequentially. Shared memory is used for communication, and scheduling used here is simpler. For example, round robin and cooperative. Here are some modeling concepts that we use here, such as finite state machines, data flow models, and time triggered models. Next, modeling in multiprocessor systems. So in multiprocessor systems, we have multiple CPU or cores. So we can execute tasks or processes concurrently, and tasks are executed in parallel. And the shared memory or distributed memory is used, and it requires synchronization and communication mechanisms. Modeling approaches: task partitioning, message passing, shared memory synchronization, and load balancing. So there are some key challenges that we face when we model multiprocessor systems. These are race conditions, deadlocks, and synchronization overhead. Race conditions means two tasks accessing same resources simultaneously. So it creates a problem. And deadlock means one task is waiting for a resource which is currently held by another task or process. So these are the challenges that we face when we model our embedded systems for multiprocessor systems. The next topic is software development process in embedded systems. Software development process in embedded systems is different from general software development process, because in embedded systems we are tightly constrained. We have limited resource, processing power, and limited memory. So these are the steps we go through when we develop software for embedded systems. The first is requirement analysis. Requirement analysis means the goals that we are building our system for. For example, what should the system do? And the next step is system design. In system design, we choose the hardware, which hardware we will use here, or the scheduling algorithm, which is scheduling algorithm we are going to use for our system. And the next step is implementation. Implementation basically means the coding part. Here we write code in C or C++. And the next step is testing. Testing, there are two types of testing: unit testing and integration testing. In unit testing, we test individual modules, and in integration testing, individual models are integrated together, and together they are tested. The next step is deployment. Here we deploy the software for our target hardware. And the next step is maintenance. Maintenance means fixing bugs and providing update and support after the deployment. So that's all. Thank you everyone.